Hello and welcome to lesson 4.4, measurement calculations in 3D. So before we begin this, what I'd like you to do is, based on the shape that you're given to the left, I would like you to determine the perimeter and the area of that given shape to the nearest thousandth. That means to the nearest 3 decimal places in centimeters. So pause the video and try that out on your own right now. Okay, so now that you've tried that, how I would do it. I would find this length right here as one of my first lengths that I need to find in order to find my total perimeter. So I'm going to call that length C, and I'm going to calculate that length by taking 3 squared, adding 3 squared. That turns out to be 18, so I need the square root of 18, which turns out to be approximately 4.243 to the nearest thousandth. Okay, I also need this piece right here, which I'm going to call M. That's 1/4 of the circumference of a circle. So M can be calculated by 1/4 of the circumference of a circle, which is given by 2 pi times whatever the radius is. So again, using my calculator to work that out, I get that as approximately 4.712. So my total perimeter is going to be 4.712 plus 4.243 plus 1, 2, 3, 4 sides of length 3. So using my calculator, I get that as 20.955 centimeters in length. I think I'll work out the area as one entire big equation. So to work out my area, I'll notice that these two squares are the exact same size. I have a triangle and a quarter of a circle. So I'm going to take the area of a square, I'm going to multiply it by 2 because there's 2 of them. I'm going to find the area of the triangle, and I'm going to find out 1/4 of the area of the circle. Okay, so to find this total area, 3 times 3 times that 2. The area of a triangle is given by base times height, which is 3 times 3 divided by 2. And the area of a circle is given by pi times 3 squared. Substituting all these values in, working out my values. I'm going to verify on my calculator. Just give me a second. I get approximately 29.569 centimeters squared. Okay, so that's how I work that out. Okay, so what we're looking at are measurement calculations in 3-dimensional surfaces today. We're going to specifically calculate volume and surface area of various different prisms and cylinders and the related right pyramids and cones. Well, a prism has the same shape on the base, so I'm going to draw a little rectangle here, another rectangle right here, and it is extended into 3 dimensions here. So this is what we call a prism. A right pyramid would have the same shape on the base, so we get that same rectangle on the base, but instead of it having the same shape at the top is just a point, and all lines, all edges lead to that point. This is what we call a pyramid. Well, if you happen to know what the volume of this prism is, and a pyramid of the same shape or same dimensions, the volume of the pyramid always turns out to be 1/3 the volume of the same size prism. So it always turns out to be 1/3 the size of the prism. Same works for a cone and a cylinder. And you can actually check out the dimensions listed on the EQAL formula sheet as well. It shows the exact same thing. So again, all you need to know are certain dimensions. Let's take a look at our formula sheet again. Oops, there it was. And you might notice that for your cylinder, it tells you need your radius and your height to work out your surface area and your volume. For a cube, you need all your lengths, base, base, base. For a cone, you need your radius, your height, and your slant height, which I give by S. For your square base pyramid, you also need your slant height, your base, and your height, length. For a rectangular base prism, you need your length, width, and height. And for your triangular base prism, you need your length, your height, your base length, and your 2 side lengths of A and C. And then you can figure out all these measurements just by calculating the surface area and the volume based on these formulas right here. Okay, so let's return to our lesson. Okay. We're going to calculate the surface area of a square-based pyramid with side length 5.2 centimeters and a height of 8.1 centimeters. So let me draw a little sketch of what I mean. I'm going to draw my square-based pyramid. And to draw a square-based pyramid, draw a parallelogram. And then you draw a point above that parallelogram and just draw a line or a set of lines to that point. So we're going to say each of these lengths is 5.2 in the base, and the height going from the center of that to the very top is 8.1. Now, according to the length, to work out surface area or volume, specifically surface area of a square-based pyramid, you need something called this slant height. So they call it by S. Well, you might notice that you actually have a right angle triangle right inside here. So you can use Pythagorean theorem in order to calculate this length of S. The height is 8.1. The length at the base is actually 2.6, which is half of 5.2. Okay, using my calculator, I get this as 72.37 the square root of this value. Which is approximately 8.507. So to calculate the surface area, which they often refer to as A, I have seen some people use SA as instead. They want the area of the base, which is 5.2 times 5.2, or 5.2 squared, plus 2 times whatever the base was, which was 5.2, times the slant height, which is 8.507. Now, if you can, try to keep this value that you have on your calculator exactly, so you can substitute it in here. If you can't, then you approximate it to 8.507, should be okay. Calculate your expression, and we get 115.513 approximately, and this is area, so centimeters squared. And there we go. There's our surface area. Let's take a look at another example. Okay, so a paper cup in the shape of a cone has a diameter of 84 millimeters. Paper cup is in the shape of a cone, has a diameter of 84 millimeters and a height of 108 millimeters. So, assuming that the actual thickness of the paper doesn't actually matter here, we're going to calculate how much paper is used to create the cup, and then we're going to create how much water does the cup actually hold. So for the first part, since we're looking for actually how much paper is on the outside part right here, which is called the lateral surface. It does not actually include the top circle. We're not actually going to cover that part. So the lateral surface is actually given by the formula pi times radius times just the slant height. So again, we need this slant height. Okay, to figure out the slant height, again, we can use Pythagorean theorem. We need the height, which is 108 squared. Sorry, 108. We need only the radius length, not the diameter, but the radius, which is 42. And we're going to square that. And this value turns out to be 13,428. We're going to square the root this value. And we get approximately 115.879. So to figure out our total area right here of this shape, we're going to take pi, we're going to multiply by the radius, which is 42, times what the slant height was, which was 115.879. And again, you try to keep your 115.879 exactly in your calculator as it is, whatever that actual value was. So when you work this out, you'll get the right answer. If not, approximation should be okay. So this works out to be about 15,289.906 millimeters squared. And again, don't forget your actual units here. So we should write a concluding statement, therefore 15,289.906 millimeters squared of paper is needed to pregnate the cup. Again, we're not assuming that you need any extra paper to fold over any parts or attach any parts together. Volume is usually easier to calculate. And part B is asking how much water does a cup hold. So that's actually looking at volume. So the volume of a cone is given by pi r squared h divided by 3. Radius, again, is 42. Height is 108. As you can see, it's just substituting the values in. And we get 199,503.700. And again, the units, millimeters cubed. So, nice concluding statement. Therefore, 199,503.700 millimeters cubed of water can fit in the cup. And there you go. So, just make sure you know what the dimensions are, fill in the dimensions according to the formulas, and calculate the values you need. Thus concluding this lesson.